Good evening, everyone. Keith Kompaltowitz from the Corps of Engineers. I'm the chief of the Watershed Hydrology Branch in our Detroit District headquarters. My branch does the water level forecasting and analysis for the Great Lakes. And like Mark said, that's just one area that the Corps has involvement in the Great Lakes. We support commercial navigation, recreational navigation, regulatory program. You know, the water levels is just one aspect of what we do in the Corps. So Mark showed a similar slide just showing our Great Lakes Basin. And the thing that I want to point out here is it's an international basin. We share these waters with our Canadian counterparts. And a lot of the work that the Corps does in the Watershed Hydrology Branch is coordinated with our counterparts in Environment Canada. So just some more Jeopardy-like stats I like to throw out. 5 quadrillion gallons of water in the Great Lakes, give or take. Probably a little taking now because we're so low. But I put a quadrillion up on a slide, and that's 15 zeros. And you look at just what 1 inch of each of the Great Lakes amounts to in sheer volume of water. A couple other stats: Lake Superior is so large it can hold all the other Great Lakes plus 3 more Lake Eries. And for water level forecasting and analysis purposes, the Corps considers Lakes Michigan and Huron to be one lake, Lake Michigan-Huron, because they're joined at the Straits of Mackinac. Their water levels on either side will rise and fall together. So here's our official coordinated water level gauge network. Mark mentioned that these are selected because of the quality and the time frame of quality data that they have provided. There is a binational or international committee called the Coordinating Committee on Basic Great Lakes Hydraulics and Hydrology Data that meets twice a year to discuss things like this, discuss Great Lakes data. And it was determined, oh geez, I don't even know when it was determined. You know, the coordinating committee's been around since the 50s. That these gauges were the best ones to use to calculate the lake-wide mean water level. And it's a key distinction. The Corps of Engineers, in the monthly bulletin that I put several out on the back, and I'll talk about it a little bit later. The Corps of Engineers forecasts monthly mean water levels, so a mean level for the entire lake surface. So to understand why water levels fluctuate, one of the things we need to understand is the hydrologic cycle. And I'm sure we've all seen a graphic similar to this, you know, in our schooling. But in a typical season in the Great Lakes, we see significant winter snowfall. That snow builds up on the land throughout the winter. When spring arrives, we see warmer temperatures. That snowpack begins to melt and feed the rivers and streams that feed the lakes. At the same time, we usually see increased spring rainfall, and those are the conditions that cause Great Lakes water levels to rise in the spring. At the same time, air temperatures are increasing as we move into the summer months. That in turn warms the lake surface temperature, and as we move into the fall, water temperatures are warmer than the air temperature that's moving over them. And then we get increased evaporation, and that causes water levels to decline. So that's on an average, that's usually what happens, but we usually don't see average conditions all the time. We see some years with greater than average snow. More recently, we've seen years with less than average snow. We've seen years with less than average evaporation, and more recently, we've seen years with more above average evaporation. So the water balance of the Great Lakes can be summed up by these 3 components that we lump together and call the net basin supply. So we have precipitation that falls on the land or on the lakes, directly on the lake surface. We have precipitation that falls on the land and makes it into the lakes via runoff. And then we have evaporation that takes water from the lake surface. Lump that together with the inflow from the upstream lake, and you have the net total supply. So if the net basin supply plus the inflow from the upstream lake is greater than the outflow, lake levels will rise. If the outflow is greater than the net total supply, lake levels will decline. So just taking you through some recent conditions of these components of the net basin supply. First one is taking a look at that net basin supply number for 2012 for Lake Superior and Lakes Michigan Huron, and you can see way more months with below average net basin supplies than above. And in fact, in September, which is the month where when I get calls and answer emails from people, September seems to be the month that everybody says the water just went away. It went down 8 inches or 1 foot at my property. And if you look at this chart, you see that September was one of the driest with respect to net basin supply that we've seen on Lake Superior and Lakes Michigan Huron. You know, some more of those the actual components that make up that net basin supply. We have precipitation was below average on all the Great Lakes in 2012. We had evaporation above average on all the Great Lakes in 2012. Michigan Huron, the evaporation totaled up throughout the entire year was 1 foot more than average. We have the spring runoff, which are the key months where we get a lot of water running into the lakes. All of those numbers were below average. And on Michigan Huron, that led to a 4-inch seasonal rise, when on average it goes up about a foot. So if you use a couple of the numbers that I had mentioned, 1 foot more evaporation than normal, and 8 inches less seasonal rise than normal, you get to where we are now with the record-setting levels that we saw in January. Incidentally, looking at some of the other lakes, Lake St. Clair and Lake Erie had no seasonal rise in 2012, and that was the first time that we've seen no seasonal rise on those lakes. So this chart, and I have to give credit to one of my employees, Dr. Jim Lewis. He developed this chart. It's become known as the Justice Scales. I think Mark named them that. But again, the upper Justice Scale we'll call is average. So if everything played out on average, you'd have the same levels every year. And the way to interpret the numbers on this chart is, so St. Mary's River. If all else in the system was held constant, the St. Mary's River would provide 23 inches of water to Lakes Michigan Huron. So that's a source of water to the lake. Holding all else constant and assuming average conditions, evaporation removes 26 inches of water from Lakes Michigan Huron. So the lower chart here, 2012, you can see below average St. Mary's River flow, which makes sense because we have below average water levels. We have below average precipitation, which I had mentioned before, and below average runoff. Here, the 38 inches of evaporation, 1 foot more than normal. St. Clair River is an unregulated river. The flow in that river is dependent on the upstream and the downstream level. So we had below average water levels both upstream and downstream. So we had below average flow in the St. Clair River. In the Chicago diversion, it's a long and at times controversial diversion of water from the Great Lakes, but it is set by the Supreme Court. And simple arithmetic of the limit of diversion is about 1 inch of water on Lakes Michigan Huron. So you can see the biggest player here that is that evaporation, that 1 foot more evaporation than normal. And that goes back to just how hot and dry last summer was. You know, I was at Grand Haven State Park one weekend last summer, and I think the water temperature was 84 degrees the day that I was there. You know, that's swimming pool water, not Lake Michigan that I'm accustomed to. But so that warm lake water coming into contact with the cool fall air, that's what caused that evaporation. So some longer term trend type analysis. The upper graph here is the cumulative departure from annual average of net basin supply. So you average up all of our net basin supply values, get the average, and take departures from that and add them up each year. So you can see we were very much above average back in the late 1990s, we had very much higher than average water levels in 1990, the late 1990s, near record highs even in 1997. Since then, we've had an annual downward trend in net basin supply. So we're seeing drier conditions, again, more evaporation, and water levels declined accordingly. One place that I'd like to point out is from 2007 to 2009, we had several above average years of net basin supply, and water levels rebounded accordingly. Then we had the sharp downturn, and then here we are with the record-setting levels that we saw in January. I have to give credit to, again, Dr. Jim Lewis of my staff putting this together. This is a look at modeled evaporation and water surface temperatures, and you can see very clearly increasing trend in both, and they're likely directly correlated. Increasing water temperatures leads to increased evaporation, less ice cover, which leaves the lakes open longer throughout the year. When you get those frigid outbreaks of air in the wintertime, we get evaporation rates higher in January and February, when usually we see the highest rates in November and December, because by the time January and February usually roll around, we've got a decent ice cover on the lake. Here's our coordinated period of average for Great Lakes water levels. Again, the coordinating committee decided that starting in 1918 was the best available water level data. The network of gauges was available. And a couple things I want to point out with in this slide, looking at Lakes Michigan, Huron, and Superior for that matter, is the 14 straight years of continuously below average water levels. That's the longest stretch in both of their recorded histories, going back to 1918. A couple other things. No discernible long-term cycle evident in this period of record. There are academic studies that point to 33-year cycles or 10-year cycles, but in this period of record, which the Corps considers to be the coordinated one, there are no cycles of water levels. There's just not enough data to conclusively determine that there's a 33-year cycle and not even 100 years of data. Excuse me. So just some current lake levels. Again, these are monthly lake-wide mean water levels. And there's that lowest ever water level ever recorded for any month going back to 1918. Moving through February, we did not set any records for the month of February. Each lake has its own set of statistics for each month. At the time, we were forecasting continued record lows, but February was wetter than average. We had more runoff. We had some freeze-thaw cycles that allowed more water to make its way into the lake. The lake rose a couple of inches in February, and we did not set any records. Moving ahead to March, again, as the lake continues its slow seasonal rise, no records again set in March. So a bit on our water level forecasting process. We've been producing the monthly bulletin of Great Lakes water levels since the 1950s. I'm sure many of you are subscribers to it. We mail it out to about 5,000 postal addresses, and maybe double that in email. So it's a very popular product. We've, again, been producing it since the 1950s. And we attempt to predict a net basin supply for each lake going out 6 months. And then we use a coordinated computer model that translates that net basin supply number into a water level. And some of the things that we use statistical analysis of past net basin supplies and past water levels. We use a large basin runoff model that our counterparts at the Great Lakes Environmental Research Lab, that's a NOAA lab in Ann Arbor, developed. We use current conditions, current weather forecasts, current reads of how streams are running, what snow water equivalent numbers look like, and some scientific judgment to come up with a most probable supply sequence. We route that through the system, and that's how we come up with our water level forecast. Canada does the same thing. Before we publish our water levels, we go back and forth with our Canadian counterparts on what we determined to be the coordinated Great Lakes forecast. So the forecast that people are seeing in Canada is the exact same forecast that we mail out in the United States. So just some current conditions. Here's snow water equivalent currently. I just put this in this morning. So you can see much more snow, especially when compared to last year at this time. And I'll go back and forth between these two slides. The key areas here are the UP of Michigan, northern Wisconsin, and especially northern Ontario on the north side of Lake Superior. This time last year, all the snow was gone. All the snow was melted. There wasn't that much of it to begin with. So it was already making its way into the system. And that was partly a part of the reason why we only had a 4-inch seasonal rise on Lakes Michigan Huron. Go back and forth a couple of times just to see the stark difference in snow water equivalent this year compared to last year. This is a model that's run out of an office, and I hope I don't butcher the acronym, National Operational Hydrologic and Remote Sensing Center. That's a branch of the National Weather Service that's in Chanhassen, Minnesota. They use all kinds of snow information from both countries, and one of the largest sources actually of snow water equivalent data are power companies. You know, companies that produce hydropower, especially in northern Ontario, where the demand for hydropower is large. They provide great data sets that are used to help validate these snow water equivalent. So moving on a little bit from that, we use long-term weather forecasts. As a meteorologist, I put limited faith in these long-term weather forecasts. You can flip a coin and often get better results, but they give us an idea. You know, they take a look at longer-term climate trends, global circulation patterns like El Nino, La Nina, the North Atlantic Oscillation, are caught up in the background discussions that make up these charts. So you can see there's a chance for above average precipitation in the Great Lakes, especially over Lakes Michigan Huron over the next 3 months. And if the downpours that I drove through on the way here today around Lansing and Portland and heading into Grand Rapids are any indication of what the spring's going to be like, look out, because some of the most torrential downpours I've seen in quite a while this afternoon on the I-96 corridor. This is a quantitative precipitation forecast for the next 7 days. And they are showing the potential for almost 4 inches of rain over southern Michigan, which includes Lakes Michigan Huron, over the next 7 days. A very active weather pattern is setting up with a stationary front that's going to kind of meander its way across the Great Lakes over the next couple days and provide abundant moisture and bring abundant rainfall according to this forecast over the next 7 days. So streams are already running high because of the increased snow melt and the increased snow water equivalent that we had this year. This is likely to compound that and could lead to some flooding situations on local streams and rivers as we head out to close this week. So considering all of that, we use information like that every month to put together the coordinated Great Lakes water level forecast. This is the monthly bulletin, like I'm sure many of you get. The benefit to getting an email is you can view the full color single lake graphics on our website. The mailed version is a black and white, all 5 lakes on 11 by 17 paper that can be a little difficult to read at times. But all of these individual lakes are downloadable on our website. I hope. We've had website issues the last couple of days, and if any of you have had problems with our website recently, I sincerely apologize. Sometimes decisions are made up here without thinking about the people that have to implement it, and that's what we're dealing with. But this is on camera, so I'll stop there. Lines on this graph, blue line is the long-term average. 1918 to 2012 makes up that period of record. The red line is the recorded monthly mean water level. The green dashed line is, again, that most probable water level forecast based on that net basin supply sequence that we try to predict. And then we have a range of water levels given very wet or very dry net basin supply conditions. Also noted are the record highs and the record lows by the hatching and associated year. So Lake Superior, let me pull out my cheat sheet here. This is still a relatively new forecast, so I haven't memorized all of the numbers yet. But we're looking at, by the summer, anywhere from 2 to 5 inches below last year, maybe by September climbing an inch or two above last year, but still well below its long-term average. Lakes Michigan, Huron, again, all the colors and lines are the same, and we'll zoom in here. So you can see that record low in January, and we haven't coordinated that yet. That's why it still shows 1965. We coordinate water levels with Canada, again, on an annual basis. So with likely the March bulletin of 2014, you will see 2013 there as a coordinated monthly low. Lakes Michigan, Huron, expecting it to remain anywhere from 1 to 6 inches below last year for the summertime. More short-term, the next couple months, 8 to 13 inches below last year, and more than 2 feet below its long-term average. Again, we do forecast a range, and if this weather pattern plays out the way they're expecting it to, I would tend to put this forecast a little hot towards the upper end of that range, just considering how high streams are running now and the prospects for heavy rain over the next 7 days and longer-term chances for above-average precipitation. Lake St. Clair, there's that no seasonal rise in 2012. We had our highest water level in January and 12 straight months of water level decline. Never happened before on Lake St. Clair. Lake St. Clair, we're forecasting to remain 2 to 5 inches below average during the peak of the summer. Anywhere from 14 to 15 inches below long-term average. Lake Erie, again, no seasonal rise, highest levels in January. We've never seen conditions like this on Lake Erie. Again, forecasting to remain below average and 2 to 3 inches below last year during the peak of the summer. And Mark touched on this very briefly. Lake Ontario was regulated. The forecast takes into account that regulation plan. It's regulated by our counterparts at the Buffalo Corps of Engineers office, and again, the same international coordination is done by with Environment Canada. The control structure is the Moses Saunders hydropower dam on the St. Lawrence River. The very basic goal of the regulation plan is to keep the lake very near its long-term average, and they do have a fair amount of regulatory ability on Lake Ontario, but that regulation does not affect the water levels of the other Great Lakes because of Niagara Falls. So this is a new slide. Again, I'm going to throw the credit right at Dr. Jim Lewis for putting this together. This is not a forecast. I want to say that very clear as day. This is an analysis of historical net basin supply conditions that we've seen over the past 113 years and running those sequences through that coordinated model to come up with water level simulations based on past conditions. So even with the wettest net basin supply sequence that we can come up with over 2 years, we're still not back to long-term average by 2014. Again, this is not like a river system like the Mississippi where they're in drought. It's so bad, it's such a terrible situation. It's very dry, significant drought. 3, 4, 5 inches of rain over the course of a week or so, and they're all of a sudden out of drought conditions. The Great Lakes don't react that way, especially Lakes Michigan, Huron, which Mark alluded to as being the largest, one of the largest freshwater bodies on the planet. It takes consistency with respect to above average snow, above average spring rainfall, below average evaporation over the course of several seasons to get the lakes up to average and to keep them there. So, excuse me, I'll touch on some physical changes in the system. Regulation and diversions are a couple things I'll touch on, and then it seems the hot button issue recently is the dredging and the deepening of the St. Clair River, which was performed back in the middle of, and prior to that, the middle 1900s and before that even. So here's another look at our Great Lakes Basin, pointing out the places with regulation points and the places of diversion. I already mentioned the Lake Ontario Control Works has no impact on water levels upstream at all because of Niagara Falls. Lake Superior, regulated at the twin Sault Ste. Marie's of Michigan, Ontario. The same complex that makes up the world-famous Soo Locks, which incidentally is another mission of the Corps of Engineers in Detroit, operation and maintenance of the world-famous Soo Locks. The government owns 8 of the 16 gates of the compensating works that are a little further north of the navigation locks. Staff in the Detroit district are members of the International Lake Superior Board of Control. And on a monthly basis, at the same time we perform our water level forecasts, we perform Lake Superior regulation. There is limited control over lake levels in that regulation plan. The regulation plan attempts to balance the levels of lakes Michigan, Huron, and Superior with respect to their long-term averages, keeping in mind that Lake Michigan, Huron is much larger than Lake Superior, so it's a standardized long-term average. There are rules in the regulation plan aimed to limit the outflow when Lake Superior is below a certain level. So when Lake Superior, and I'm going to go out to the meter side of how we measure lake levels, when Lake Superior is below 183.4 meters, you can release no more than what would have normally gone down the river prior to any man-made change. And that's currently the criterion that we're operating under. Lake Superior is well below 183.4. Right now we are releasing from Lake Superior what would have gone down the river given no man-made influence. That's about 1,530 cubic meters per second. A lot of people ask, well, why don't you just open the gates and send more flow down the river? If you were to double the current flow rate of 1,530, you'd be able to raise, and again, holding everything else constant. That's the important thing here, holding everything else constant. You could maybe raise Lakes Michigan, Huron by about an inch. At the same time, doubling the outflow would lower Lake Superior by about 2 inches. That's just rough arithmetic. If you were to cut it in half, you would lower Michigan, Huron by about a ½ inch and raise Lake Superior by about an inch. Again, very rough mathematics, but just shows that there's limited control over lake levels at the regulation point at Sault Ste. Marie. Diversions. I'll touch on Welland Canal and New York State Barge Canal diversion first. The Welland Canal was built to allow ships to get past Niagara Falls. It doesn't divert water out of the Great Lakes Basin. It just provides another avenue for water to flow from Lake Erie to Lake Ontario. The Barge Canal helps the water flow in the New York State Canal system. Again, it makes its way back to Lake Ontario eventually. Chicago diversion. Back in early 1900s, the Chicago River flowed into Lake Michigan. The Chicago River was heavily used as a dumping ground, if you will, for the city of Chicago. Polluted water made its way into Lake Michigan, past the city's drinking water intakes. They brought that polluted water back into the city. People drank it, people got sick. They decided to reverse the flow to protect Chicago's drinking water supply, and for other reasons, navigation comes to mind, flood control, things like that. Prior to the most recent Supreme Court decree, there was more water diverted out than currently. There are studies that have been done that the overall impact of the Chicago diversion is a permanent lowering of Lakes Michigan Huron by about 2 inches. That's long term over the course of over 100 years. The simple arithmetic of the current rate is about 1 inch of water. The Supreme Court limits the diversion to 91 cubic meters per second, or about 3,200 cubic feet per second of water that's diverted out of the Great Lakes into the Mississippi River Basin. Up here in Lake Superior, we have 2 diversions of water into the Great Lakes used to generate hydropower. They divert 5,200 cubic feet per second into the Great Lakes. So when you do all the math and come up with the net diversion, there's about 2,000 cubic feet per second more water diverted into the Great Lakes than is diverted out. So St. Clair River compensation. The timeline shows a history of man-made changes and deepening in the St. Clair River. Started back in the 1800s with often undocumented dredging to allow for ever-increasing ship size. There was also unchecked sand and gravel mining that occurred up until about 1926. There was a federally approved, internationally approved deepening project that commenced from 1910 to 1923. Another one, again, internationally approved and carried out. The Corps just carried out these dredging projects as that's our mission. These are all internationally approved. Canada had to buy in on these projects. The Corps was just the agent that carried out the deepening. So 33 to 36, the 27-foot channel, which was authorized in 56, was carried out between 58 and 62. Since 1962, there has been no deepening of the St. Clair River. There has been maintenance dredging to maintain the authorized depth, but no further deepening has been done in the St. Clair River. Incidentally, since that last project was completed in 1962, we set record lows in 64, record highs in the 70s, record highs in the 80s, near record highs in the 90s. So since the last deepening, we've had 2 instances now of record lows and 2 instances of record highs and 1 of near record high. All that put together, the early dredging, the sand and gravel mining, the 3 internationally approved projects, accounts for 10 to 16 inches of permanent water level loss on Lakes Michigan here. That's over the long term. It is not currently contributing to the low water situation that we're seeing. Again, only maintenance dredging has occurred in the federal channels since 1962 in the system. The International Upper Great Lakes Study, which was an IJC-funded study that the Corps of Engineers had a large role in, also determined that there was some erosion that occurred in the St. Clair River from 1962 to 2000. Could have been an ice jam, it could have been the periods of high water which caused increased flow. That accounted for another 3 to 5 inches of water level decline, but again, that is not currently continuing. The river bottom has determined to be stable. Since 2000, there's no ongoing erosion. So, investigation into St. Clair River compensation. These images came straight out of the International Upper Great Lakes Study. It's the website is www.iugls.org, and if you go to the Lake Superior final report, you can view and read Chapter 7, which talks about the study into compensation, and these images of potential, theoretically possible compensation structures are all there. There would be potential adverse impacts. I don't remember the high water of the 80s, but I see pictures of substantial shoreline erosion. Maybe those folks would be against compensation, which could lead to higher water levels in the future. I don't know. Downstream at Lake Erie, there could be potential negative impacts with further water level decline there. Again, we don't know. So this is kind of the lesson in Corps of Engineers Civil Works funding. The Corps just can't decide one day to go out and build something. You have to have the authority from Congress, and more importantly, often you have to have the appropriation or the money to do it. So, according to the Boundary Waters Treaty, which created the International Joint Commission, any project that could impact levels and flows of the Great Lakes or connecting channels must have agreement between the United States and Canadian governments and or International Joint Commission approval. So there's one thing you have to look at, because compensation, like the dredging, would impact levels and flows of the Great Lakes. So in order for the Corps of Engineers to construct those compensation structures, I mentioned that we have to have approval and appropriation. The project that I mentioned on that timeline that was approved in 1956 for the 27-foot navigation channel did contain language for compensation. We believe at the Detroit office that that authority remains. That has to be vetted through the chain of command, if you will, through our division office in Cincinnati and our headquarters office in Washington. And unfortunately, I don't have a time frame on that. If it is determined that authorization remains, the Corps could budget in its fiscal year 2015 budget for funding to reopen the investigation of compensation that was done in the past. There was a study done in 1972 by our Waterways Experiment Station that looked at structures to compensate for the past dredging. There's no guarantee that we would get that budget request fulfilled. It would compete nationally and internationally with all kinds of other requests from other Corps districts and offices for planners. And again, it has no guarantee of eventually making it through to the President's budget, because that budget request has to go through the same chain of command, if you will, as the authority does. So here's my contact information. I'll be around. I have business